Okay, another example. Given is a sector of a circle of radius 21 centimeters. There is there is there. Okay. Find the length of the perimeter, that's from here down to here and back to here. Use 22/7 as an approximation for pi. So the length of this sector part here is equal to theta over 360. Theta is equal to 60, multiplied by 2 by pi by r, which is 21. Okay, but the perimeter of the whole thing is this length of the arc AB, this plus 21 plus 21. So the length of the arc AB is 60 over 360 degrees times 2 times pi times r. Okay, all plus 42, and I nearly forgot that myself. So that all works out at 22 plus 42. The perimeter is OAB is equal to 64 centimeters. Okay, the area of a circle. The area of a circle is given by area is equal to pi r squared. Okay, that's the area of the circle in there. And the area of a sector of angle theta is, and radius r is equal to theta over 360 degrees by pi r squared. So, first example, find the area of a circle of radius 14 centimeters, use pi equals 22/7, and then after that, find the radius of a circle of area 1386, use pi key for this one. Okay, so the area of a circle is given by pi r squared, so that's equal to 22/7 by the radius 14 times 14, that's r squared, and the 7 will cancel that into a 2, so we have 22 times 2 times 14 is 616 centimeters. And then if we know the area of part 2 of the circle is equal to pi r squared, then r squared is that over pi, because just divide both sides by pi, they cancel, and here's our pi here. So r must be equal to the square root of 13865 over pi. R is equal to 21 centimeters. Example 3, the length of the circumference of a circle is 120 centimeters. Find the radius. Well, the circumference equals 2 pi r, so 120 equals 2 pi r. R is equal to 120 over 2 pi, which is equal to 60 over pi. So r is equal to 19.1 centimeters. Now, more practical examples from page 96, page 96, question 12. So, here we go. Find the length of the running track here, okay? Use pi equals 22/7. How many laps if someone was in a 10,000 metre race on this track? Well, the length of the track is given by the circumference of this circle. There's half the circle there and half the circle there. So that's involved in the length of the track, so is that. So that's 2 pi r. Okay, and we know r because this is 63, the diameter. So half that, 63 over 2 must be r. Plus 2 times this length here, 1 for there and 1 for there. So that's 2, and I always like to put it over the 1 just to keep it balanced to look at visually, times 22/7 times 63 over 2 plus 202. So work this out separately now, don't get it clumbered up with this. So all of that, 2 goes into that once and once, and 7 goes into that 9 times, so 9 22s is 198, plus 202 is 400 metres. And so if 1 lap is 400 metres, x laps in 10,000 metres, equate them together and then just cross multiply. So x by 400 is equal to 10,000 by 1. So x is equal to 10,000 over 400. X is equal to 25 laps that they'd run around this track in a 10,000 metre race. Now, question 19, page 97. The quadrant shown is cut from a circle O. Here's the quadrant here. And remember, it's cut from a quarter of a circle, so that's why that's 90 degrees. This is 14, so that must be 14 too. Find the area of OAB, of that triangle. And then find the area of the shaded region, which is here, using pi equals 22/7. Okay. So the area of that triangle, if I just tip this triangle down this way, sorry, so I'll do it like this, which you'll see it here. So it looks like this now. This is 14 because it's the radius of the circle, as is this. The circle's touching around, if you like. Okay. So the area of this triangle is half the base by its the area. Oh, bear with me a second now. Yeah, sorry, it's half the base of 14 times the height. Okay, I thought I was doing something with r squared there, but it wasn't. So the area is equal to half the base here times the perpendicular height. Okay, so this goes in once, because that's 7 times 14 is 98. That's the area of that triangle. Then we'll look to find the area of the sector, because once we know the area of all of this, we take away the area of the triangle and we'll just have the area of the shaded area. Okay, so the area of the sector is theta over 360 degrees by pi r squared, r is 14. So it's 90 over 360 times 22 over 7 times 14 over 1 times 14 over 1, which represents the r squared. So this cancels out, we get a quarter. This will go in there twice, so we get 22 times 2 times 14 all over 4, it's 154 centimetres. So the area of the shaded area then, here, must be equal to the whole arc minus the triangle. It's equal to 56 centimetres squared. Okay, now mention of rectangular solids, otherwise known as cuboids. So here's one here, length, breadth, height, okay, like a box. And here's a cube, and this is a cube because each side is 1 centimetre in length, and the volume of that, it would be 1 by 1 by 1 cubic centimetre. Okay. The volume of a cuboid, this fella here, is given by multiplying its length by its breadth by its height, and the surface area, that's the area of all the sides behind the ones underneath you can't see, is found by adding 2lb plus 2lh plus 2 by b by h. Okay, and the volume of a cube is found by L cubed, and the surface area of a cube is found by 6L squared.